let's first click the plus sign on the left up corner. And we will first use the terminal to download the data we need. So let's hit the terminal. Because I already have that in my directory, so I will create I will just create a like Tuesday tutorial folder. And let's go to the Tuesday tutorial folder. Okay, it's an empty folder. And next we will download the tutorial package by, so you can see the command is already pinned in the Slack channel. It's git clone with URL at the end. So you can do is git clone this URL. And then you can just download all the tutorial data. So this is actually a very basic downloading downloading the code and tutorials into your own local local computers. So for more information about Git or GitHub, you can see the pinned information in the Slack channel, like Git 101 or GitHub 101. But we will not like get into much details of this. So as you can see, we create the if you click the tutorials on the left panel, and then you click the water data. So that's all the Jupyter notebooks we will be using today. So if so the one I am going to give today is point data tutorial. So you can click the point data tutorial and it will show you the notebooks. And it asks you to choose a virtual environment. This is default, and we will use the conduct environment column Waterhackweek. So we choose this one. And the goal of my presentation today would be, I want to show you guys how we, by the end of the presentation, you will be able to get access to the GIS shapefiles and of the river basin boundaries and the river networks. That's like the two basic shapefiles we usually use to make our spatial maps. And you will also know some basic skills of plotting spatial maps, as well as downloading precipitation and stream flow data use WOMO, and also conduct basic statistic analysis using pandas. So first of all, I will show, so this is some packages we will be using today. And when we say package, if you are not familiar with Python, basically each package is an ensemble of the functions, which is already pre-written by like more professional coders. So you can easily use some functionalities of this modules. For example, like NumPy is the most basic packages which people use to deal with numbers like arrays or a list of numbers. And pandas is we are going to mostly use today is you can imagine this as a spreadsheets, which you have columns and rows, and you can like selecting the numbers by just indicating the column names and row names. And SciPy is sorry.
Can I interrupt very briefly, just responding to concerns in Slack that
Right.
some people are not following along or they're not in Jupyter Hub. And just wanted to say that this is all set up so that everyone should be able to do exactly what Yifan is doing and run it on your own and follow along by running exactly what he's running, but you don't have to. That's your choice. you can just sit back and watch. It will all be available. All the tutorials will be available for future use. And if anyone has any problems running any of the tutorials later on, please let us know. We definitely encourage you to actually try to run it, even if it's not during the presentation.
Thanks, Emilio. Yeah.
Yeah, I just want to second that because I just told that to Jill as well. I think like if you haven't run a Jupyter Hub before, this will go too fast for you, and it's better to pay attention, run through it later with the recording, and then just ask us questions if you get stuck. So
Cool. So yeah, so the next one is SciPy, and we use SciPy a lot for some more advanced statistical studies like linear regressions or things like that. And the important package we will introduce today is WOMO, ULMO, and this package has been a great package which assembles a lot of the portals to download data from a lot of different agencies. For example, like USGS and National Weather Service. So I will show you today how we can actually find the sites and download the data from the WOMO. And the next one, several packages here introduced like Matplotlib, Folium, Cartopy. Those are all plotting packages, as Bart just mentioned. Matplotlib is actually the most widely used in basic plotting packages, which you can use to plot like line plots, scatter plots, or all different kinds of plots. And Folium is an interactive, it's a great package for interactive maps. And Cartopy is mostly used for plotting maps. So GeoPandas is a package which you can actually use to access shape files or like GeoTIFF files, which is very handy to deal with shape files and also like the remote sensing data. So the last one importing, so this one, sorry, I accidentally added there. So today, the table of contents is here. I will first talk about our study domain, and also the second part is to access precipitation and streamflow data using WOMO, and the last one, I will do some site-specific point data analysis. So first of all, we choose our study domain to be the Yakima River Basin. And so every basin is attached with a HUC number. And Bart just mentioned if the number is long, then the basin is smaller. So the one we chose here is like HUC 8. So it's about, so I will show you guys later how big it's it. And when I first, usually when I first know our one study domain, the first step I would do is to plot the spatial maps, like to know where the recent boundary is and what's the main river networks in this shapefile. So I would first do is to download the shapefiles and also to download the shapefiles of the river networks. And there is a really great website the USGS put together is this one. And even though if you cannot like run the notebooks, but you can still open the notebooks and you can click this URL and this will lead you to this website. And if you can click the national map downloader, like green button here, go there, okay. And it will point you to this website and you can see, so there is like a lot of different data sets you can download that the NHD, which is the river network, and also the water boundary data set is the water boundary. So the first one, we want to know where the water boundary is. So if you click the water boundary data sets, and it asks you to click the data extent, because we are more interested in the Yakima River Basin, which is here in Washington State, and it's very close to, it's about 2-hour drive from Seattle, and you can click the HUC region. in order to like more precisely choose the data, you can like click the box and point and zoom into the scales where the basin is located. For example, here I draw a rectangular over here and it zooms to Washington. Then you can click find products. So then it will return you the products that we will be using here. So you can like actually download the boundary files here. And similarly, you can also do this same thing to download the river network data. So let's run through the notebook. The first, let's load the modules. And then this is the HUD region we chose. And we can read in the shapefiles, which I have already pre-downloaded, so you guys don't need to worry about that. And this is the GeoPandas and the shapefiles. It looks like this looks like a data frame. So the first number 0, 1, 2 here is the index, and also like the bolded top here is the column names. But the only thing is different from a normal data frame is it has like the last column called geometry, which shows the shape of the river boundaries. So basically we select the river boundary, select the river basin we want here. And we can also show, so this is how, what the river basin look like. So the next one, we also read in the river network file. I want to highlight here, there's two normally used river networks. So the first one is called an NDF plus, and this is a very high resolution river network. So this would be really handy when you're trying to do some small scale studies. And but if you are more interested in like a subcontinental or like regional scale studies, then you can probably be more interested in the geospatial fabric, which is coarser resolution, and this is designed for the national hydrology models. And for illustration purpose, and today we will only be using the national hydrological, the geospatial fabric. So here we read in the river networks. This is also interactive with the GeoPandas. So the next one is we can actually plot in the spatial maps. I will not get into details, but so first of all, you can see through Cartopy, you can actually, it already has a lot of the natural Earth features like the state boundaries, country boundaries already implemented in the data in this package. So you can actually just click run. And this one actually plots two spatial maps. So for the left one, this is just the spatial map of the Yakima, of the upper Yakima River Basin, with the red shows the domain, and with the blue shows the river networks here. And in order to show where this location actually locates, we can see the right map. You can see it actually locates in the center of the Washington states here.
Hey, Yifan, can I make a suggestion?
How
about closing the panel on the left to give you more real estate?
Oh, good.
There you go.
Thank you. Thank you for the suggestion.
Can I make one more comment? In this Slack channel, we're answering people's questions, but we're typically using kind of a reply directly to that question, so that there's a little sub-thread to kind of organize the responses a little better. So Philip, for example, if you kind of scroll up to your original questions, there are question, there are 4 answers to to that particular question. That'll keep the Slack organized a little bit better.
Cool. Thanks for the comments. So the next one, there's another handy tool to just quickly look at the domain is volume, and we can actually make some interactive maps. So if you run those 2 shells, you can see the background is the domain for the entire United States, and you can for the globe. So you can actually zoom in and zoom out to take a look. And I want to say the background information is actually embedded in the volume package, while the shapefiles, you see the blue boundary shapefiles is actually the information we just from the shapefiles. So you can see for the Yakima River Basin, it's very interesting because the upstream part of the boundary is in the forest, while the downstream part of the river basin is in desert. So today's tutorial, I want to just basically follow a story is trying to understand whether we want to know whether precipitation is a good indicator to predict the stream flow. So all the following analysis will be like surrounded by this research question. And so how are we trying to handle this is we're trying to assess whether precipitation can be a good indicator to predict the stream flow. So if it has like really good linear relationships or things like that, and we can actually use precipitation to predict the stream flow. So there are 2 parts we want to look at. The first is interannual variability. We want to check whether the annual precipitation is linearly correlated with the mean annual stream flow. And the other one is seasonality. We want to know whether the precipitation seasonality is similar to the flow seasonality. So in order to do that, first we will download the precipitation data and stream flow data using WOMO. So you can see the following is the WOMO supported the following data set. There's a lot of different data sets available here. And today we will be using the national climate data and the USGS National Weather Information System data. So the first is we trying to collect the precipitation information. So we first is download all the available precipitation data in the Washington states, and we're trying to filter out the sites which is in our study domain. So we transfer this pandas data frame, which shows the latitude and longitude, into a GeoPandas item, so that and then we can find the sites within our study domain. So you can actually draw a spatial map and take a look whether
Yifan, may I make a quick question? Can you go a little bit slower on the individual commands, because as a viewer, you skip so fast to the next one that it's impossible to follow along with what you're actually doing, and explain a little bit more like how you actually, what these commands are actually supposed to do.
Okay, yeah, sure.
Thank you.
Sounds good, thanks. So I will start here. We use the package WOMO, and we chose the data sets like this one. And so this command is here, is we're trying to find all the available sites all the available sites with precipitation data in the Washington states. And all the data here is output as the pandas data frame, as shown in the as shown below here. So so the next one, we are because this is all the precipitation data available in the Washington states. So we're trying to find only the precipitation data sites available in our study domain, and we can actually use we have the boundaries like of the shapefiles of our study domain. So we just want to select the sites within our study domain. So this sites is we transfer the location like the latitude and longitude of our sites into like the geospatial GeoPandas point data, and we can use this line of the code to just select the sites within our study domain. And the next one, I just want to show you whether this code works or not. So you can see the blue lines are all the sites in the Washington states, and I highlighted the sites within our study domain using the red dots here. So you can see it's actually works. So the next one, we just draw the interactive maps so that you can have a better visualizations. And so the next one, we just like download the precipitation data from using WOMO as well. So WOMO can not only like import the available site information, but you can also directly download the data. So basically, we chose two precipitation data sites. One is upstream in the forest, and the other one is downstream in the deserts. So we can directly use this line to download the data, the precipitation data of the sites, and just run the code. So and the precipitation data looks like this. It's actually a data. The individual data sets is so this command will output a dictionary with the keys to be the variables you are interested. So the precipitation downstream, and then if you click, like, if you just say precip here, and it will output a data frame which has all the data available for the precipitation. So the next one is trying to change the index of the format so it can better be used later. And there's a very quick way to take a look at the data sets is you can just type in the variables you're interested in precipitation and type in values and dot plot here. So you can have a very quick look at the data you are interested, the time series of the precipitation data. Okay. So the next one we're trying to, so now we have the precipitation data, and the next one we're trying to gain the information data within of the streamflow data. So we use the USGS NGUIS portal to download this. So the one good thing about the USGS is we can directly use the HOC number to download the precipitation, the streamflow site information. And if we take a look at the output, it's actually output a dictionary format data, and it has 20 USGS sites here. And if we take a look at the keys, is all the USGS site numbers, and we randomly, so we chose one site which is actually located downstream of the Yakima River Basin. So you can have the better representation of the general water availability in this river basin. So we take a look at what does the site's information look like. It contains all the information like the name, the networks, the agency, location, like latitude and longitude. So to better like, in order to like easier process the data, we extract the latitude and longitude from this site informations. And we also transfer this this dictionary into a data framework, and it looks like this. So use dot head is just to show the first 5 rows of this data frame. So the next one is just you can easily like transfer the transfers the pandas data frame by simply using dot t. So basically the columns becomes the rows and rows becomes the columns. And the next one, we add 2 columns in the back, which shows the latitude and longitude of this data framework. So you can also see like the different site types. There is also like a lot of different, so there's a lot of different site types, and the code can be defined, can be found through this website. So we can also actually see the locations of all the USGS sites in this data domain. And so this is how it looks like. So the next one, we're trying to download the streamflow data of the selected sites. So the one here, you can see we have, it calls a parameter code. And the parameter code is to show whether it's a streamflow data or it's a stream temperature data. And all those parameter code is available through the links here. And there's also statistic code, which is whether you want the maximum data minimum, like daily maximum or daily minimum, or the mean average data. So here we download the streamflow data and we download the mean streamflow data, and we define the start date and end date to be, so basically it's download all the data sets within this period. We run this one, and we convert the data format to pandas data frame using the several line of codes here. Okay, so it seems I'm running out of time. So the next one in this section 3, I'm trying to. Oh, sorry.
As for the running out of time, don't speed up. Just keep going the way you're going. Since you have the notebook available to everybody, they can step through it if you do run out of time. If you're a few minutes over, that's okay too. But so don't speed up. Okay,
cool. So yeah, I will keep my pace. Sorry. As just for a recap of the packages we usually use in to process the data is we use NumPy, we use pandas, because pandas already has is built up based on NumPy and matplotlib, so we can actually easily use pandas to do some like simple analysis and do some quick check of the data sets. So, and also SciPy is built on NumPy and matplotlib, can perform some more advanced like statistic, like linear regression. And there is a scikit-learn, which is built, which is a more advanced package, which is built on NumPy, SciPy, and matplotlib. This is also can be simple and efficient tools for predictive data analysis, like classifications, regression, clustering, which can also be some like machine learning algorithms. So the first one is you can use this sites to, so DF is the data frame, and we can quickly take a look at the data set by just simply using dot plot, which I used this code before to take to have a quick look at the data set. But in order to produce more not fancy, or like the plots which is ready for publication, you can also use, you can also define like the size of the plots. You can also add the X label and Y labels, and also you can add legends, which I will not cover here. And the next one is data selecting and indexing. So basically we can select the data sets. We can select the columns. We can also select using the index. By selecting columns, we can simply just df and add the the column name of this site, add the column name after. And if we want to select index, remember we need to use dataframe.lock and add the index behind. If we want to select a range of indexes, we can add doc, so data range can be a list of indexes. So there is another one is we can select the data range. Basically, for example, if you want to download, if you want to, if the time series is not continuous and you want to select the time periods only within a select time period, you can just define the start date and end date, and using like slice to then you can select all the data sets within this time period. Okay, so for some basic statistics, it's very easy to calculate here. Is you can just use the data frame and use .mean, so you can calculate the means for this data frame, and there's some attributes you can define there. You can calculate the means metrics in a single columns. Like for every column you calculate the mean, you can define axis equal to 0. And if you want to calculate metrics along each row, then you define the axis equal to 1, like this. And there is a very simple way to get the summary of the metrics. You can basically just select the using .describe. And then you can see what's the count of this number and what's the mean value, standard deviation, minimum value, and the 25, 50, and 75 percentile of the value. So the one, okay. I will stop.
So Yifan, actually, I would say run through the data aggregation, then the final part, whether precipitation is a good indicator for stream flow, people can step through for themselves.
Right.
And we'll use that time to ask a few questions, okay?
Yeah, thanks. So for so the last one I want to introduce is data aggregation. So this one is very important because we usually get for example, we get the data at minimum at like minutes or like hourly data, and we only show the result at like daily or monthly data. So we can easily do this using resample and group by. So it's kind of hard to directly describe how does the difference between resample and group by. So basically, if you have so here we download all data from 1910 to 2020. So we do, the resample is to upscale the temporal resolution. So for example, we download here is daily data and we upscale it to mean monthly data. So it's still a time series and the resolution, it has a coarser resolution. The other one is group by. So for example, if we want to know the seasonality, like we basically just group by all the data in January, or we group by collect all the data in February, and then we take the average value. So this is group by. And this ends up being seasonality. It's not time, it's end up not be like a direct time series data. Okay, so I will stop here. I have more materials following behind to just show has aggregation of the of all the tools I introduced above to show how we can use these tools to access a simple research question is whether precipitation is a good indicator for stream flow.